In today's lesson, we're going to be solving equations using algebra. And algebra, when you solve algebraically, it involves two key pieces: using inverse operations in your work and keeping your work balanced or equal. The learning target: I can apply my understanding of identifying totals and parts in an algebraic equation, so I can use inverse operations and balance to solve equations algebraically. I'll know I've got it when I get an 85% or better on this assignment. Okay, so we are going to have you look at these equations in the next few examples, and what I want you to do is to take a look at it and identify which of the three terms in this equation are the parts and the total. So which two are the parts in the equation and which one is the total amount in the equation? And I want you to write those down on the lines. Parts, totals. Turn the video back on when you think you've identified the parts of the equation and the total. Okay, so hopefully you identified the two numbers that are being added together are the two pieces or parts that will generate this total amount right here. So 4.8 and x are the two parts that when you put them together, you get one part or one total. And that is those are the three values. Now, what's missing here is a part. So I'm going to put part here. A part is missing. And when you're trying to find a part, you're either going to be subtracting to find it because you already have the total and you already have one of the pieces. So to find the other piece, you got to subtract from the total. So in this case, it's an addition problem, so we'll subtract. When we're trying to find a part, we either subtract or divide. In this case, it's an addition equation, so we're going to subtract. So it's 37.2 minus 4.8, and you can use calculators, so get out your calculator and do the math for that, and then put your answer on the line. So you should have gotten 32.4 when you punched that into the calculator. So this was an addition setup, but to solve it, we used subtraction. Addition and subtraction are opposite operations. Another word for opposite is inverse. So we had to use, we chose to use inverse operations here because it's a very efficient way, especially with the calculator, to get the solution to this equation. And you can always take that number that you got here, 32.4, plug it in here to check it. When you add these together on your calculator, you should get 37.2, the target number. If you don't, you have the wrong answer. Okay, so here's the next one. I'm going to circle this guy right here. And just because I want to identify the variable in this. And then what you want to do is I want you to identify which of these pieces of the equation. You have two terms here, this one and this one. I want to know which two pieces of this equation are the parts and where's the total. How much is the total? Write them on the lines and then unpause the video to see if you got them correct. So you should have identified the two numbers being multiplied together as the parts. These are factors, and we're multiplying them together to get a total or a product or a multiple. So our two factors here are the parts, and our 418.18 is the total. So what's missing? A part again. We're missing a part. And we have a total. We got the total using multiplication. So to get the part, we got to divide. We got to divide to find it. So we're going to set this up. Now remember, you're in the algebra world with variables, so you got to use the fraction bar. Do not use this symbol right here. No, no. Don't want to see that in your solving at all. So we're going to take the total. This is key. The total goes on top. And we're going to divide by the factor or the part that we know. That always goes in the denominator. So the numerator is always your total, top, total and top. And then the part or the factor goes underneath. Now punch that into your calculator and see what you get. You should have gotten 72.1. Now, if you think about it, 5.8 times 72.1 is what we're plugging in here to check it. And when you plug in 5.8 times 72.1 on your calculator, it should come out 418.18. And then you know you found the right solution. You used the right operation, you didn't make a mistake. And you're using a calculator, so your accuracy should be there. Okay, in this equation we have W divided by 42. Let me just circle my variable to identify the missing, what's missing, and we have to figure out if that's total or part. So identify your two parts in this division. W divided by 42 equals 8.93. And then turn the video back on to make sure you have the right three pieces. Okay, so you should have identified that the total is missing here. We're taking a total amount. Remember, it's sitting on top of that division. We're dividing by a part or a factor of 42. And after we do the division, we get 8.93. So we're missing a total here. To get a total, we're going to either add or multiply. You add and multiply to make totals. In this case, since it's a division problem, I need to multiply my two parts together to get what this total started off as. So I would need to multiply my two factors. So I'm going to start with 8.93. And I'm going to multiply by 42 to get that total. So you're going to pause the video, dump that in your calculator, and then turn the video back on to see what you get for that total. So when you multiplied 8.93 times 42, you should have gotten 375.06. And again, just for the check's sake, you can just punch in the 375.06 divided by your total divided by the 42. And when you punch that into the calculator, you should end up with 8.93. So just check it when you're done with your calculator by plugging it back into the original equation, solving and checking, right? To see if you got the right value here. If it doesn't come out to 8.93, you've got the wrong solution. Maybe you didn't use the right operation to solve it. Maybe you punched the numbers in backwards. You got to figure out if it doesn't work. Okay, another thing I just want to point out, this was a division problem at the setup, but we were missing the total in this division problem, so we used inverse ops. We did the opposite of division to solve it in an efficient way. We used multiplication to get to that answer with our calculators pretty quickly. Okay, this is our final example in this piece of the lesson. Identify the total in the two parts for the given algebraic equations. And I'm just going to identify the variable here. And I want you to identify where are the two parts. We got three terms in this one. Where are the two parts? And what's the total amount? When you've identified that, turn the video back on to see if you've got the right parts and total. So the two parts are on different sides of this equal sign. We got 4 and 6/7, 6 and 2/7. And my total is missing. It's the variable, so I'm missing the total amount. Since I'm missing the total amount, I should add my parts together to get that total. So we're going to use addition. It's a subtraction equation. We're going to do the opposite of subtraction to solve it in an efficient way. We're going to take our two parts and add them together. So 6 and 2/7 plus 4 and 6/7. And when we add those together, we get 10 and 8/7 because we add just the numerators of the fraction. You got to remember your fraction stuff. 2 plus 6 is 8, and they're sevenths, 8/7. And 6 plus 4 is 10. And then that 8/7 can be 1. That's 8/7 is 1 and 1/7. So I'm going to add the 1 to the 10, and I get 11 and 1/7. So you're going to have to do this with decimals and fractions today, mixed numbers and whole numbers. So you can't forget your decimals and fraction operations. The decimal stuff will be easy on a calculator, but your fractions, you're going to have to work those mixed numbers and fractions out. Okay, identify the inverse or opposite operation for the given operation. We just did those 4 examples, and as I pointed out as we went through, we were using the opposite operation to solve all those. So it's super important to be understanding what the opposite operations are for these 4 operations. So the inverse or opposite of adding is subtracting. And the inverse operation of subtracting then must be adding. So you're going to be looking for that today. The inverse of multiplying is dividing. Therefore, the inverse of dividing is multiplying. Whoops, not spelling that right. Multiplying. So part of our learning target today was to use inverse operations to solve these algebraic equations. And you should, at this point, recognize how to solve an equation efficiently using that inverse operation. Okay, so in this problem right here, before we jump in, I just want to point out what we just went through and what is coming up. So when we're looking at this box right here, it's basically summarizing what we just did with our last piece of 4 examples. We were identifying what operation we needed to solve those 4 equations. And how we did it was we looked for what we knew, what parts, what numbers we had in the problem, and where the variable was. And if the variable was a total, if the variable was a total, we didn't know the total, then we had to either add or multiply. All right, if it was a subtraction problem, we would have added. If it was division, we would have multiplied to generate that total. And so you should have a really good sense of that. And then if we were missing a part, we should have known to take the total and subtract. If it was an addition problem missing a part, we would take that total that we knew and we'd subtract the other part and we'd find our solution. Or you would take your total that you had in the multiplication problem, you were missing your part, and you would divide by the part you knew and you get the other part that was missing. Okay. When we're looking at the equations today, we can keep this definitely in mind. This is a good piece to know. If you don't have that, it makes algebra and understanding the process we're going to use today more challenging. But there is a bit of a shortcut without having to always think where's part, where's totals, that kind of thing. And that is called just, hey, if you're solving an equation and you have an expression, an algebraic expression, that has a missing value to it, then you can just know I'm going to use the opposite operation to solve it. So if it's an addition, to solve it, you know you should subtract. If it's multiplication, you should divide. If it's subtraction, add. And if it's division, multiply. It's just without having to think about all of this, you know inverse operations, after all we've done with them, should be what we use to solve these equations. Okay, so solving algebraically means 2 things. You've got to keep balance. This is new today. We have not been showing balance in our solving so far. And to keep balance, we're going to use inverse operations, but we're going to use inverse operations on both sides of this equal sign. We're not just going to do inverse operations to find the solution. We're also going to use inverse operations to do what we call isolate the variable. In this case, the variable is x. So I'm going to walk you through the process of how it looks to solve an equation algebraically. And this is the learning target today. These several examples that we're going to do together is the learning target. It's the way you have to show your work when you're asked to solve algebraically. So the first thing I want you to do is I want you to draw a line between this isolate and find the solution all the way through your equal sign. Try to be neat. Mine is a little sketchy there, but it'll work. So we're separating these two expressions. We're really emphasizing that there are two expressions on the opposite sides of the equal sign. We've got this expression with the x on it and the minus 17, and we got 36 over here. And now we're going to think about how to solve this. Well, to solve this, it's subtract 17. So we're subtracting 17. So to solve it, I need to find x. I'm going to circle it. I want you to circle your variable. I need to find x, which is a total. To solve and get a total here, I'm going to need to add 17. The 17 is on the side with the variable, so it's one of the parts, and the other part is over here, and I need to add them together in order to get this to work. And I am going to write my work vertically for this addition or subtraction problem that I'm using addition to solve. So over here, I'm just going to write plus 17 right underneath my 36 because I know that's what I need to do to find the solution. And you should know that too. Looking at this, you hopefully knew I need to add 17 to 36. And since I'm doing vertical math, I'm going to draw a line here. This represents the equal sign for vertical math, and you have to have it. So make sure you draw that in. Can't leave this out. We're doing vertical math. And when I add that together, I get 53. So now I know the solution. And what we're going to do now is we're going to do the new piece that you're learning today. You are not allowed to just say x equals 53 here. You have to show me how you isolated x, how you get x by itself. Isolate means alone. X is not alone right now. It's got a minus 17. How am I going to get rid of a minus 17? Well, you get rid of it by adding 17. Minus 17 plus 17 gives you 0. So when you add 17 on that side of the equal sign to this expression, x minus 17 plus 17, and we do this math, we get x plus 0 equals, our equal sign stays here, comes down. So we just made a new equation here. It started off as x minus 17 equals 36, and I just made a new one, and it reads x minus 17 plus 17 equals 36 plus 17. And when I simplified that new equation, I got x plus 0 equals 53. When I did this math, and I did this math, my next equation was x plus 0 equals 53. Now I can simplify a number plus 0. Any number plus 0 is just that number. So I can drop the plus 0 and get x equals 53. So I think you know, hey, this is what I do to solve. But you're not allowed just to solve and get the solution. You also have to isolate the variable, keeping balance, inverse operations on both sides. We know to add 17 to this side, so to keep balance, I must add 17 to this side, and it'll all work out so that you isolate x and get 53. Okay, here's our next example. And just again, this is a reminder that, hey, you can just look at the equation or you can think about total parts and look at the equation and identify what operation you're going to use. And then you need to look a little further at the equation to see how you're going to show that on both sides of that to keep that balance. So this, we're given a multiplication equation, so we're going to use division to solve it. Okay, and when we use the division, we have to isolate the variable and find the solution, not just find the solution. So we're going to draw a line down our equal sign. That's required. We're going to circle our variable neatly. That's required. This all has to be done neatly, so please take your time in your notes and do it neat because that's the expectation. Personal best handwriting on these equations. Okay, now looking at this, you probably know that you're missing a part And when we're missing a part in a multiplication, it's a factor, right? You're missing a factor, and you know that the other factor is 8. So to solve it, you're going to divide by 8. Probably that you should recognize. So on this side, I'm going to just divide by 8. That'll give me my solution. And we can punch that into a calculator. We're using calculators on this lesson. And if we divide 104 by 8, punch it into that calculator. 104 divided by 8, you should have gotten 13. Okay, but right now there is no balance on this because you did something to this side and you didn't do it to the other side. Whatever you do on this side, you got to repeat on the other side. That's the requirement. So the good news is you know to divide 104 by 8, so you know on the other side you have to do the same thing. So you just write it and you see what happens. Well, you get 8 divided by 8. Well, 8 divided by 8 is 1, and x. You get 1x equals 13. This is that new part. You're not used to this. So we get 1x, 8 divided by 8 is 1, and the x is sitting right there. Well, 1 times x is just x by itself. We just dropped the 1 to simplify that expression because you don't need it. And your solution is 13. And you're good to go. So by dividing by 8 on both sides, it served 2 goals. Goal number 1, you found the solution 13. Goal number 2, by dividing by 8, you got x by itself. So your equation is x is 13. It tells the solution in the form of a math sentence. Okay, so we have, again, this equation, x plus 58 equals 236. And we are trying to solve for x algebraically. So looking up here, I was given an addition equation, so I'm going to use subtraction to solve. If you think about it, we're missing a part. These 2 parts make the total 236. So to find the other part, I need to start with the total and take away one of the parts. So I got to take away 58. That's the thing you got to recognize. So we're going to circle that variable. We're going to draw a line down our equal sign as straight as you can get it. Oh, that was pretty good, not bad. And I'm going to say, okay, well, if I want to find this missing part, I got to take my 58 and minus it from 236. So start with what you know. What are you going to do to 236? Write it down. And then we do this vertically. And because I'm doing vertical math, I'm going to put that equal sign in there. And I'm going to get an answer for that. You can punch it into your calculator. And when you do, you should get 178. But right now, I haven't gotten where I can say x equals here because I haven't done anything to get x isolated. I have to do something to this expression to make this plus 58 go away. And it's right here. Whatever you do to get the solution, that's what you have to do on the other side. Inverse operations. If I'm adding my part to x, that means I got to subtract that part on both sides. That's the new piece today. If you don't show it on both sides, you're not learning what was being taught today. So you have to show it like this. And I'm putting that bar in because I need an equal sign to show me what I'm going to get. So the equation was x plus 58 equals 236. I turned it into a new equation. X plus 58 minus 58 equals 236 minus 58. And when I do this math on this side, I get x plus 0. So that minus 58 got me the solution and it got me x isolated because x plus 0 is x. It will work out when you use balance. It will make this goal happen right here. You'll isolate and get the solution doing balance. Okay, inverse ops. So when you circle your x and you see a plus 58, you know that's what you're going to minus on both sides. It'll generate the solution and isolate your variable so you get that math sentence at the end that states x is 178. This is set up as required. There are no shortcuts. This is it. This is showing how to solve the equation algebraically. Okay, so looking at our equation, we need to solve it algebraically, keeping that balance, which means you're going to show me how you isolate or get x alone, showing me the math you're using, and on the other side, showing me the math you're using to find the solution. So we're going to draw a line down our equal sign. We're going to circle our variable, and we're going to think about what operation it takes and what number we need to use to solve this. We are missing a total because that's a division problem. We have the two parts, 6 and 24. So we're missing the total. To get the total, we look at the variable and we see that it's divided by 6. That's what we're doing to our missing number. So to get the solution, we're going to multiply both sides by 6. I'm using a dot for multiplication. Do not use this symbol for your multiplication. No x's here, because it's a variable. You'll confuse everybody if you use an x. Okay, so we're going to multiply by 6. So I'm looking at the 24 and I knew that. Hey, I know I need to multiply this by 6 to get that missing number. Times 6. We use the dot times 6. Now, to keep balance, we do the same thing on the other side. To get rid of divide by 6, I'm going to extend my division line and I'm going to multiply by 6. To multiply by 6 means you just set it next to the variable on this side. No dots or anything. Just extend your little divisions fraction bar and drop the 6 right next to it. Now we're multiplied 6 on this side and this side. Now we do the math we just wrote on both sides. We're going to simplify. So if you dump 24 times 6 into your calculator, you should get 144. So we just do the math. We just clean up. We had x divided by 6 equals 24. We changed the equation to 6 times x divided by 6 equals 24 times 6. And now we did the math. We're creating our new equation in the next row. On this side, we have 6x divided by 6. 6 divided by 6. These cancel. These cancel and they make a 1. 6 divided by 6 is 1. 1 times x is 1x. So I get x equals 144. X is 144. So by doing inverse operations to get the solution here and matching that inverse on the other side, I was able to get the equation that tells me exactly what x is. Isolated the variable and found the solution, all by multiplying both sides by 6. Okay, so here we have an equation, x minus 9.7 equals 18.5. So the first thing I want you to do is recognize we're going to isolate on this side and find the solution on this side by doing inverse operations on both sides. So we're just going to draw that line down the middle. We're going to circle our x. I'm going to identify that, hey, I have a minus 9.7. So to solve this, to find the total, because I'm missing a total, to find the total, I'm going to add 9.7 to both sides. And when I do that, it'll isolate my variable and I'll find the solution. So I went to the side with the variable, I circled the variable, I saw what I was doing to it, I'm minusing 9.7, so simply add 9.7 to both sides. And when I'm writing it vertically, I'm doing vertical math, just easy to set up because then I don't have to rewrite everything, just a quick way. So it was x minus 9.7 equals 18.5. I turned it into x minus 9.7 plus 9.7 equals 18.5 plus 9.7. Now I got to clean up all this stuff that I wrote. Well, it's not hard. Minus 9.7 and plus 9.7 are 0. Because they're inverses, they're opposites. On this side, when I add this, I just dump it into my calculator. And when I dump it in the calculator, I get 28.2. And you should be using a calculator as well. So balance, because I did the plus 9.7 on both sides. I did inverse operations on both sides. It isolated x, served a purpose to isolate x, and on the other side it generated the answer to the problem. Again, this side you guys typically understand very well. This is the new stuff today that you've not had to do in the past. But this is required. If you're not showing me this and you're just doing this, you're not going to get full credit because you haven't learned anything new today. You have to show me that you understand that I have to do the balance on both sides. It's called a property in algebra when we do that on both sides. It's called the addition property of equality here. Adding the same number to both sides will give you a new equation, but it's the equivalent equation. Okay, we haven't been checking our solutions above. I just wanted to get into the practice of being able to solve, but now we're going to start plugging in to show how it should check. And you have calculators, so you can use those to plug in. But this is how the check looks. If you're asked to show an algebraic check or prove that a solution works, you have to start with the original equation, and then you take the value you got for x and you plug it in to the original equation. And we did this in a previous lesson, so we're going to walk through a check. So we plug it in, we're going to draw that line down our equal sign, put our equal sign in, and I'm going to put that question mark. Hey, is 28.2 minus 97 going to give us 18.5? That's this just brought down. So I rewrote the equation. I just replaced the letter with the number for it that we got. And then you dump this into your calculator. You do the subtraction. And your goal is to hopefully get 18.5. Let's say you don't get 18.5. You do here. So I'm just going to write it down. This comes out 18.5, and you bring this down and you compare. If they're the same, then you did the problem correctly. You found the right solution. If this does not work, 28.2 minus 7 doesn't give you that, it means go back here and check your work. Did you do the wrong operation to solve it? Did you punch numbers incorrectly into the calculator, make a careless error? You got to figure it out. Because these should match. This expression, when you use the number, should come out to the same as the expression on this side when you compare these two. All right, here's our next one. So we are trying to figure out x. We're trying to find the solution to x using algebra, solving algebraically. So circle your variable, draw a line down your equal sign. That's always the best place to start because it helps to let you focus in on, oh, I can't draw a straight line today. I'm going to use my cheat. You guys do your best to draw a nice straight line. Should be easier with paper pencil than drawing on a screen. Okay, so I've got that done. I've got my variable circled, and I'm just kind of analyzing, this reads 1.2 times x. It's multiplication. So to solve this, I'm going to use division. And I'm looking at the side with the variable, and I'm going to say, hey, since I'm dividing, I have to divide by that other part that's next to the x, 1.2. So I'm trying to find a part, and I'm going to divide by 1.2. I'm going to put P for part, divide by 1.2 to do it. So to find my solution, I know I've got to take this part and divide the total, 34.8 divided by 1.2. So by drawing that line down the equal sign and going to the side with the variable to figure out what operation, division, inverse of multiplication, what number, the number that sits with the variable 1.2, divide by 1.2. So I wrote it here, and I have to keep balance. I know it's going to get me the solution here. This is the weirdness. You don't necessarily understand fully what this is yet, but it's to isolate x. Whatever we do here to get the solution, we do here to isolate x. Or when you identify, hey, the inverse op is division, and the number I need to get rid of to get x by itself is 1.2, just do it on both sides. Okay, now we're going to do the math on this side. 1.2 divided by 1.2, that's just a number divided by itself. You know that's 1. 1.2 divided by 1.2 is just 1. 1 times x is 1x. So I'm just simplifying the math I wrote. Okay, the equation 1.2x divided by 1.2 equals 34.8 divided by 1.2. Punch that into your calculator. 34.8 goes first, divided by 1.2, that goes second, and you'll get 29. 1 times x is not in its simplest form. We know 1x is just x by itself. X equals 29. And that is the solution. Okay. Now you're asked to check it algebraically. That doesn't mean scrap the work. It means you have to formally show how this relationship works with a 29. So we're going to draw a line down our equal sign. I'm going to put that question mark in because I'm asking, hey, when I put in the number I got, it's 1.2 times 29, will I get this number here, 34.8? That's your first row of work for an algebraic check. It's just showing what you're putting in for that missing value that you found. The next step is to dump it into your calculator. How easy can it be? 1.2 times 29, and when you do that, you get 34.8. So you just write down the math. We're funneling this expression here. On this side, there's no math to do. We just bring it down. And we're comparing to make sure the values are the same. And they are. They match. So we did find the right solution. 29 was the right number. So solving algebraically means inverse operations shown on both sides so that you're isolating the variable and getting the solution. And once you have it, an algebraic check is very formal. It's plugging the number in and funneling that math on the left side while bringing down the right side to prove that you have a match. This is the required steps when you're asked to solve and check equations algebraically. Okay, in this next problem, we have been dealing with some decimals and some whole numbers, and now we have the fractions and mixed numbers. You are responsible to have mastered adding, subtracting, multiplying, dividing, whole numbers, decimals, and mixed numbers. So we're going to do a practice to just get you back in the groove for how the fractions may work in here. So I put that line down the equal sign. I'm going to circle my variable. And I'm going to think about what's happening here. Okay, I have a part and I'm adding another part to it to get a total. So I need to isolate x, which means this plus 3 1/3 needs to go away. So to get rid of this plus 3 1/3, I need to minus 3 1/3. Also, I know if I have the total in a part, I need to minus 3 1/3 from 8 4/5 to find the answer. So we're going to do that on both sides. Minus 3 1/3. If I do it on this side, I'm getting the x by itself, and then I'm minusing 3 1/3 on this side. And I'm going to put my equal sign in there. That's that straight line across. That's our equal sign when we're doing vertical math. So I started with the equation x plus 3 1/3 equals 8 4/5. I created a new one. X plus 3 1/3 minus 3 1/3 equals 8 4/5 minus 3 1/3. I'm just using inverse ops on both sides, keeping balance, so I can get x by itself and get the solution. Okay, so now we have this mixed number situation, but I'm looking at this and I've got 8 4/5 minus 3 1/3. I do not have a common denominator. You need to remember that when you're adding and subtracting fractional parts, you need to have a common denominator. So you may need to go off to a scrap sheet of paper. If there's not enough room on your paper, I gave you additional workspace for this problem. So you have to keep in mind, and we are using a calculator, but the calculator is not going to be helpful here in the situation of just doing your problem for you. You have to know to get common denominators. And the common denominator for a 5 and a 3 you should know is 15. They both go into 15 evenly. And to create these equivalent fractions, I'll need to multiply 5 times 3, and I'll have to do the same to the top, which is 12. This should be review. And to get the equivalent fraction for 1/3 in 15ths, I have to multiply 3 times 5, 1 times 5. And then I will just do the math over here with my new and improved. I'm going to rewrite the problem with my new and improved equivalent fractions with a common denominator of 15. That's a terrible 5. And neatness does matter. See, I erased and rewrote, even me. Okay, now we start with our fractions before our whole numbers in case we have to borrow something. 12 take away 5 is 7. So I have 7/15 here for my fraction. And 8 take away 3 is 5. So I've done all this work off to the side, and I'm now going to bring my solution down. So my solution to this equation is 7/15. And on the other side, I have a plus 3 1/3 and a minus 3 1/3. Well, that's 0. Because we're isolating, that would make sense. And we get x plus 0 equals 5 7/15. Well, x plus 0 is just x, and x equals 5 7/15. So we're just funneling down to get an equation that states the solution in a nice sentence. X is 5 7/15. Now we need to check our solution. So we're going to take our 5 7/15 and we're going to put it in here. Draw your line down your equal sign, neat as you can, right through it, and put that question mark in. Because we're saying, hey, we got to make sure that our solution is correct. That's a terrible question mark. Do that again. There we go. Equal sign goes right under it. So I found that x is 5 7/15. So I'm going to write 5 7/15 right here for x. I have to make sure I can fit this expression in neatly on this side. So you have to know your space. It's got to fit neatly. So I've got 5 7/15 plus 3 1/3 on this side. And I'm saying, hey, does that give us this number that we have on the other side in our equation, 8 4/5? Again, I don't have common denominators here, but I can come over and have some additional workspace. I have 7/15 and 1/3. 15 is the common denominator. So I'm going to take the 1/3 and I'm going to change it into 15ths. By multiplying 3 times 5, what you do to the bottom, you got to do to the top. Now I have 5 7/15. I'm going to just do the math over here off to the side. Or I could write it underneath. I guess I could do that too. 5 7/15. I could funnel it right here. Plus 3 5/15. Doesn't matter. You could do it off to the side or right underneath. And we're still wondering, is that going to be 8 4/5? Right now, I'm not sure. Too much had to happen in here. I'm not done. So I'm going to add first my fractions together. 7 plus 5 is 12. 15ths. And 5 plus 3 is 8. Okay, I've got the 8 to match, but I'm not sure about that 12/15. It doesn't look like 4/5. But 12/15 is not in lowest terms. So you might think you got it wrong here, but you got to look to see if this can be reduced. They both have a common factor of 3. So we have to divide that 3 out of both. There's some steps. You got to remember your stuff. And you get 8 4/5. It did work. You got to remember your fraction stuff. So we were okay on this one. And again, you might need to do some work. It might take some steps to get to this. You have all the skills. We've covered them this year. This is where you're going to apply those skills. Okay, so we have this equation right here, and it looks a little different because if you look and you draw your line down the middle of your equal sign, like we're doing, and you circle that variable, you'll notice that the variable is no longer on the left side of that equation. So it's on the right side. Doesn't matter. We still do the same steps. Okay, so we're looking at this right here, this side, and we see we have two parts that make a total of 256, but I'm missing a part. So to get this, I'm going to do the inverse of adding 123 to x. I'm going to do minus 123 on this side and this side. When I minus it on this side, I'll isolate. When I minus it on this side, I'll find the solution. It will serve two purposes. All right, do the minus 123 here and over here. Draw that equal line. Because we're doing that vertical math, we need an equal sign. So the equation was 256 equals x plus 123. I just created a new equation that's equivalent, but it looks different. 256 equals x, 256 minus 123 equals x plus 123 minus 123. Now I'm going to do the math for that and punch it into your calculator, but I think it'd be faster just to do it vertically here. We're in hard numbers. I get 133, and on this side I get x plus, these are opposites, plus and minus 123 makes 0. Okay, so I get 133 equals x, because that 0 can be dropped. So I've now got my solution and I've isolated x. To check it, we're going to draw a line down that equal sign, put our question mark in. Equal sign underneath, and I have 256 here. That's in the original equation, nothing to do there. On this side, I need to put in the 133, substitution, and I'm adding 123 to it. And then I just either dump it into my calculator or do the math myself on that one. I get 3 and 3 is 6, 2 and 3 is 5, 1 and 1 is 2. I get 256. There was no carrying or anything there, so it was pretty easy to do straight up. 256 equals 256. So I substituted into this whole equation. I performed the operation on this side, and it came out the same as that side. So we solved algebraically. Remember, your goal is to be able to show inverse operations on both sides and clean it all up to get your answer and your x on the other side. And then your goal for an algebraic check is to start with the original equation, replace the variable with the number you found, substitute, and then simplify to prove you've got it. Okay, we have one, we are down to, let's see, how many more? This is our final example together. Okay, so we're going to first draw a line down our equal sign. Circle your variable. And decide what we need to do. This equation reads 17.8 equals x divided by 10.2. My x is on the side with the divide by 10.2. So the opposite of dividing by 10.2 is multiplying by 10.2. That's what I'm going to do on both sides of this equal sign. I'm going to multiply both sides by 10.2. When I do it, whoops, these should be switched. Just an FYI. Got them backwards. When you do this, you should end up finding the solution on this side and getting x alone on that side. So I'm going to extend my division sign a little bit. And I'm just going to drop the 10.2 right next to the x to the right of it. Okay, that doesn't look like proper algebra notation, but when we're solving, you can do that. Because if we try to put it over here and squeeze it in, it's going to get messy, and you don't want to have to rewrite it in front down here. That's an extra step you don't need. So you're allowed to just say, hey, I'm going to multiply by 10.2 instead of putting it in front where the coefficient is. I'm going to stick the coefficient after. It's right there. And on this side, we're going to make sure our dot is up in the middle. You don't want it down like a decimal because we got a lot of decimals here. 10 point, here's the decimal, 10.2 on both sides. Make sure you fit that in there neatly. Okay, so on this side, you're going to drop it into your calculator. Go ahead and do that now. And you should have gotten 181.56 when you did that math. On this side, we're just going to read, hey, it's 10x times 10.2 divided by 10.2. 10.2 divided by 10.2 is 1. So we get 1x here. And then we just simply clean that up because we can drop the 1 in front of that x. So we make another row of work here. We bring down our solution. We bring down x, and we get that nice sentence that says, hey, 181.56 is equal to x. And now we just want to show how we check, how we prove we've got it algebraically. So we start with the line down the middle and that question mark saying, hey, we're checking. We want to make sure that when we put our number in that we got, we end up with the same number on the other side. So 17.8, does it equal 181.56 divided by 10.2? So this just comes down 17.8. There's no math to clean up on that side. But write neatly, gotta erase that, write it again. On the other side, you drop this into your calculator. 181.56 divided by 10.2. And my display says 17.8. And now I go, good, that's what I was hoping to get. So if that's the case, this is the right solution. I did this correctly. So this is the end of the video of working together on these. Not the end of the lesson. You're going to have to do some practice problems to make sure you're understanding it on your own. So there may be another video to follow. The key again is to find that variable and find out what you're doing to that variable and then do the opposite on both sides to solve it. If you can remember that and show the inverse on both sides, you'll be in great shape. Always remember you can plug that number back into the original equation that you got for your solution to make sure you didn't make any errors when you were finding it, doing that algebraic check. Good luck.